So this lesson is going to go over graphing linear functions. One thing I would suggest is that you have a ruler handy so that you can draw straight lines. So the first thing we're going to look at is our slope-intercept form example. So when I'm given slope-intercept form, I know the slope and I know the y-intercept. So our slope here is 2 over 1. So this will be how much I'm going up since it's positive, and this will be how much I'm going to go to the right. And then our y-intercept is the 0.01, because I get that from this number here. So I'm going to go to the 0.01 on my y-axis, and then I'm going to go up 2 and to the right 1. And I can repeat that a few times to the right to see what the graph looks like going to the right. And I can do the same thing going to the left, except I'm going to do the exact opposite. I'm going to go down and to the left. So I'm going to go down 2 and to the left 1, down 2 and to the left 1. That way I see a clearer picture of what's happening both to the right and to the left on my graph. And then I can connect the points and look at that function. So this is the graph of 2x plus 1. I see a y-intercept of 1, and I see a positive slope that goes up 2 and to the right 1. So that's slope-intercept. The next one we're going to look at is y equals -3. So if I'm thinking about what my slope would be in this case, I have no value in front of x because there isn't an x here. So in this case, my slope is actually going to be 0. It does not show up in my equation, so I know that coefficient in front of x was 0, and my y-intercept is 0, -3. Now what this is telling me is I'm creating a graph where y is always -3. So I'm going to go to that y value of -3, and I'm going to create a line that shows all of the other possible points where y is -3. That tells me I'm going to have a horizontal line that connects all of these points where y is -3. So if I look at what that line would look like, make sure I actually make a straight line in this case. This is my horizontal line that shows all possible y values being -3. So anytime you see y equals some number, you're going to get a horizontal line. The next form we're going to look at is point slope form. So I'm given a point and I'm given a slope. So I'm going to do this pretty similarly to how I did slope-intercept form, except I'm not starting at the y-intercept. I'm starting at this point within my equation. So my slope is here in front of my parentheses. So in this case, it's -3 over 1. So instead of having a graph that's going up like this, I'm going to have a graph that's going down since the slope is negative. Now, if we remember point slope form, it's y minus my y value and x minus my x value. So I'm going to take the opposite sign of what I see in my equation. So here x is -1. That means in my point it was positive. Here I see y plus 2. That tells me in my point that y was negative. So I'm going to start at the point 1. -2. And I'm going to now use my slope. So this tells me, in this case, since it's negative, I'm going to go down and to the right. So 1, 2, 3 down over 1. 1, 2, 3 over 1. And again, I went down first because this is a negative slope. Now, if I want to look at the opposite side of this starting point, I'm going to do the opposite of what I wrote here. So I'm going to go up 3 and left 1. So I usually try to put at least 5 points on my graph for graphing before I connect the line. I'm trying to make this dark so it shows up really well on my camera. So this is the line that represents this equation. And the last one we're going to look at is standard form. Now, in standard form, the first thing that I'm going to check is my x and y intercepts. Because to find an x-intercept, I substitute 0 for y. And to find a y-intercept, I sub in 0 for x. So I'm going to start by taking out x and putting in 0 here for y. So I have 2x minus 0 equals 4. And this is to find my x-intercept. So this is going to say that 2x is equal to 4. And then dividing by 2, I get that x is equal to 2. So this tells me where I cross the x-axis, right here at the point 2, 0. Now I'm going to do the opposite and substitute in 0 for x if I'm trying to find my y-intercept. So I'm going to take x out and replace it with 0 minus y equals 4. Well, 2 times 0 becomes 0, so this will be gone. So I'll have negative y equals 4. I don't want negative y, I want positive y. So I need to divide by negative 1. So y would be equal to negative 4. That tells me my y-intercept is 0, negative 4. 1, 2, 3, 4. And I can connect these 2 points. And that would be my line from using standard form. Now, if for some reason, when I was substituting in 0 for x and 0 for y, if my answer was a fraction, then what I would do instead is I would rearrange this equation to make slope-intercept form. And again, I would only do that if my x or y-intercept ended up being a fraction. It is very unlikely that if you're given a standard form equation that you'll see that fractional intercept. But just so that you're aware, it is possible. All right, so let's take that one away and go to our extra examples that I printed out for you. So this first one we've been given is in point slope form. So I'm going to use my slope of negative 2/3. So this means I'm going down first and then right, or up and to the left. And then I'm going to use these coordinates here, those values in my equation, to find my starting point. So remember, if it's point slope form, it's always the opposite. So this is going to be -1 and +3. So I'm going to go to -1 up 3 to my first point. And now I'm going to use my slope. Since my slope is negative, I know that ultimately my graph is going to go this way. I'm going to be decreasing. So I'm going to go down 2 and to the right 1, 2, 3. Down 2 and to the right 3. On the flip side of that, I'm going to go up 2 and to the left 1, 2, 3. Up 2 over 3. Now I have 5 points here, so I'm going to go ahead and take my ruler and connect the dots. And again, I'm making my line thicker just so you can see it better on my picture. So that's another example of graphing in point slope. Now I have a standard form. So I'm going to check and make sure I get whole number intercepts, and if not, then we'll tweak it. So I'm going to start by trying to find my x-intercept. So I'm going to replace y with 0. So I'm going to have 9x minus 3 times 0 equals 18. This will turn out to be 0. So I'll have 9x equals 18. And we're in luck. I'm going to get x equal to 2. So I know my my x-intercept, where y is 0, is 2, 0. Now I'm going to do the same thing with x. And I'm going to replace x with 0, meaning I'm finding my y-intercept. So I've got 9 times 0 minus 3y equals 18. That's going to turn out to be 0, so I'm going to get -3y equals 18. Dividing by -3 gives me that y is equal to -6. So my y-intercept is 0, -6. So I'm going to go ahead and count down 6. 1, 2, 3, 4, 5, 6. There is my y-intercept. And I'm going to connect those. And there's my graph. All right, flipping this over. Now this is sort of similar to that other example we had where y was equal to -3. However, this time it's x being equal to -3. So this is actually going to be a vertical line. If we have a line that's vertical, this means our slope is actually undefined. If you remember back to our last unit when we were talking about functions, a vertical line does not count as a function because it has multiple output values for that same input. So if I go over to where x is -3, all of the other points, both up and down on this vertical line, are where x is equal to 3. So all of these points on this vertical line would count within this defined line. However, this is not a function, so I cannot define the slope because it doesn't fall under the overarching title of a function. I still can draw that line based on this information, but it doesn't count as a function, and so we write that our slope is undefined. All right, last example. So I have slope-intercept form. So I know this is going to help me find my y-intercept. So I'm going to go to the point 0, -2. So there's my y-intercept. And then this is my slope. So I know I'm going up 3 and to the right 4. There's my next point. Up 3 and to the right 4. And then if I want to go in the other direction, I have to do the opposite. So I'm going to go down 3 and to the left 4. Down 3 and to the left 4. And connect those. And there is my line. So just as a reminder, with our zombie activity to practice graphing, when my camera unfreezes, you have the graph with all the different zombies on it, and you have this sheet with all of the different forms of graphing. So your mission is to take each of these equations, graph them on here, and figure out which zombie gets caught by which line. You will only hit one zombie at a time with each line. So down here at the bottom, you're going to tell me which equation hit that zombie. Now, if you have scissors and glue at home, you can cut these out and paste them into each box. If you don't have scissors and glue at home, that's totally fine. Just write the equation into these boxes, and then you'll take a picture of this paper, and this is what you're going to submit to me on Canvas. If you have any questions, send me a message and let me know.